Hello friends. So in this series of video, we are going to discuss few important aspects of uninterrupted power supply. So let us see the content, what we are going to see or what we are going to discuss. So we are going to discuss about power problems, UPS and its output performance, classification, comparison between different UPS, how to size the UPS, and redundant deployment architectures of UPS. So now we will see first power problems. So we have 9 different type of power problems basically. The first one is power interruption. So this means the utility or the supplier cuts the power to the consumer either intentionally or it could be because of any fault. Okay. So this is very common type of a power problem. Second one is voltage sag. For a short duration of time, the voltage is reduced to 10 percentage, almost 10 percentage from the normal standard values. So almost 90 percentage of the standard value you get for the load. So this type of voltage dip is called as voltage sag. Voltage swell is nothing but just reverse. So a 10 percentage voltage more than the standard value for a short time period, not for a long time, it's a short time period. So this is called voltage swell. Under voltage or brownout is a voltage sag which sustain for a minute or more than a day. So this could be more than 10 percentage as well. If it goes for a long time, it could damage the devices. Over voltage, it is the voltage above the standard values. Either it could be for a few minutes or it could be for few days as well. Again, this could damage the load as well as the installation in your building. Electrical line noise. So this could be because of radio frequency interferences or electromagnetic interferences. Switching transients. So when we switch on the load or remove the load, so this kind of transients may appear for a little while. Frequency variations. So as a standard frequency 50 or 60 Hz should be maintained for the loads. In case of changes in the frequency either above or below, so this could cause also a problem to the system. Harmonic distortions. This is mainly because of the power electronic devices which we are using in our day-to-day life. So this is another major problem. So overcoming these type of problems and to give us solution for this kind of problems, we go for a device called, though it is not for the whole network, at least for your load, you can do a kind of a protection against this type of problems. So the device used to protect your load or system against this type of fault is called as UPS, uninterrupted power supply. Basically, this UPS provides the power to the load when the utility fails to give the power. It depends upon the size and the configuration of the UPS, how much time it could back up the power to the load. Usually, the UPS used for short time period So this short period is used to change over between the utility supply to the another source. Either it could be coming from the battery, or it could be coming from the other sources like generator or so on. So this short period of time period, the UPS should provide the power so that the system will not shut down without saving the information properly. And in many critical cases like banking, servers, then telecom networks, some manufacturing processes, we need the power without any interruption. And also the voltage surges in the input or due to the load changes should be also suppressed. So based on these all problems, we are going to design a UPS, and we are going to utilize them for different application with different configurations. So an UPS is a autonomous source of alternate power that is used to supply sensitive electronic loads such as computer centers, telephone exchange, many industrial process control and monitoring system, medical applications, and so on. So the output performance of the UPS is classified with the three categories: the input dependency, output voltage waveform, and dynamic output performances. So first let us see what is input dependency. Input dependency in the sense the output of the UPS depends upon the input voltage magnitude and the frequency, or is it independent of these parameters? Based on that, we can classify the input dependency of that UPS. So we can have three categories under this: the UPS which is having voltage and frequency dependent, the UPS which is voltage independent, and the third one voltage and frequency independent. The second parameter is about output voltage waveform. What is the type of output we get from the UPS in a normal mode and stored energy mode? What is normal mode? When the utility is providing the power, what kind of output waveform we have for the load, that is normal mode. And stored energy mode, in case of the power failure, the energy stored in the battery is given to the load. During that time, what type of waveform we have for the load? So based on these two, we classify again the UPS. So if you have the sine waveform in the output and it has a total harmonic distortion very less, then it is denoted as S, and medium THD sine waveform is denoted as X, and if you have quasi or square wave output waveform, then it is called as Y. So the two common waveform types are sinusoidal or non-sinusoidal. X are very less used. Nearly all UPS rated 2 kilovolt ampere and above are classified as SS type. So in a normal mode as well as in stored energy mode, it will have pure sine waveform and less total harmonic distortions. And the UPS which is below 2 kilovolt ampere, the input when it is available, the supply is available, it provides a sinusoidal output waveform, and in case of the stored energy mode, it provides only a non-sinusoidal or square waveform. So it is X, S and Y. And the third parameter is dynamic output performances. So this dynamic output performance is how much time it takes to change over between the stored mode, like a normal mode, to bypass mode or to the stored energy mode. Is there any power interruption? Is there any voltage variations? And if it is there, how much time it takes to settle down? So based on that, we are going to have three different classification again here. So the no interruption with 20 percentage plus or minus voltage regulation up to 10 milliseconds. So this will be numbered number 1. And second one, up to 1 millisecond interruption, that is only 1 millisecond interruption with 20 percentage voltage regulation, and it will settle down in 10 milliseconds. The third, number 3, is up to 10 milliseconds of interruption time with 10 percentage and minus 20 percentage voltage regulation in 100 milliseconds time delay. So these are the three different types. So now the UPS is classified into three basic categories: static UPS, rotary UPS, hybrid UPS. In the rotary UPS, we have all mechanical parts or electromechanical devices. We don't have any power electronic components here except the static switch. This rotary UPS system works like this. So you have the supply, AC supply from the utility. The power goes to the AC motor, and the AC motor runs. When the AC motor is running, the motor generator set here is going to function as a generator, and it is going to produce the voltage which is going to be stored here in the battery. And also the same coupling, you have a generator here, AC generator, so which is going to run and going to provide the required power to the load. So this is the normal mode of operation. So AC supply is given to the motor is going to run. So the motor is coupled with motor generator set as well as the generator set. So there is a motor generator set which is a DC machine. So now it is going to act as a generator, produce the electricity and store the energy produced there in the battery, and the generator, AC generator, is going to produce again the electricity and it is going to feed the load. So because of the AC generator producing the voltage or the supply, so we can control the type of waveform what you want and phase angle and everything here. And in case of the utility supply is not available, when the utility supply is off, that time the process goes in different way. Now here the motor goes off, the power not available here. So from here the battery is going to feed the energy to the motor generator set. Now this motor generator set is going to function as a motor, and this motor is going to drive the AC generator. Now this generator is going to produce the power and the load is going to function, right? So this is about the stored energy mode. Even in the stored energy mode, you will have a sinusoidal output waveform because the alternator is connected to the load, right? So in case of any maintenance work for the battery or motor generator set or AC motor, we can have the bypass pass supply through the static bypass switch. So this is about a rotary UPS system. It has its own advantages. As I told you, it is reliable than static UPS system. It is a mechanical device, electromechanical device, of course. So the transient overload capability is up to 300 to 600 percentage, and good performance for non-linear loads, whether it is the R load, RL load or RLC load, irrespective of the load, it gives a good performance. Very low input current THD, that is total harmonic distortion, is very less, almost less than 3%. Low EMI electromagnetic interferences and high efficiency up to 85%. So these are the advantage, and the disadvantage comes where it requires more maintenance because of its rotary parts, and of course it has a big size weight compared to static ones, because we have a motor, generator, and again the AC motor. So all this consumes a big space as well as a weight. So these are the advantage and demerits of a rotary UPS system. And there is a hybrid UPS system where we are going to replace motor AC, the AC motor here. Instead of that, we are going to have a AC motor. Before we had a DC motor generator set, now we are having a AC motor or generator set. Okay, so now the AC supply will be feeding the load through. Now the AC motor is going to function as a motor generator set. So it is going to act as a motor. It is going to prime move the device. So when the prime mover is running, then generator is going to generate the power which is required to the load. And same time, the power also given to bidirectional AC to DC converter. So that means it can act as a rectifier as well as it can act as a inverter. So in this mode, now it is acting as a a rectifier, so which converts AC supply to DC, and it is stored in the battery charger. So this is the normal mode of operation. When there is a power failure, so the supply won't be available from the AC supply. So now we need to take the power from the battery. We will take the power from the battery, and now this bidirectional converter is going to act as an inverter, so which is going to convert the DC into AC. Now the AC motor is going to run. The AC motor is going to run, and it is going to couple the generator. So the generator is going to run, and the load is going to get the power. And during the maintenance of any of these device, we can also have a bypass path with the static switch to the load. So this is a hybrid. So where we have a rotary parts as well as a static part. So there is an inverter converter device here. Also we have a motor generators here. So we are just feeding the motor, AC motor, with the inverter, and the AC motor is coupled to the DC AC generator, so that the generated output here will have less distortions, and also it will have less harmonics and all kind of problems. Okay, so it will have a better solution, and the weight and the space requirement also a little bit reduced, because of we are eliminating one DC motor generator set. So coming to the static UPS types, we have many types in this. Basically we classified into offline and online. So in offline mode we have standby and standby ferro, and online we have line interactive, double conversion, and delta conversion type of UPS. So any basic UPS will have these elements: a rectifier or charger, which converts the AC to DC power, and inverter. So the inverter will convert the DC to AC, and battery stores the energy, and static switch used to switch over between one mode to another mode. Now we will see standby UPS. The black diagram representation is given here. So here we have a EMI filter. We have 230 volt supply here. This 230 volt supply is coming from the utility, and it goes to EMI filter. Sometimes we have surge suppressor also. Here they are represented as a EMI filter, and so this filter will remove the noises which is coming from the line, and the power will be flowing to the static switch. From the static switch, the power will be given to the load. And meanwhile, the rectifier unit converts the AC supply into a DC, and the DC filter rectifies the noise which is produced from the rectifier unit, and it feeds the battery to charge. So two things are happening in this normal mode of operation. So during this time period, our inverter and AC filter static switch is in silent mode, so it is not going to do any function. Okay, so the load is taking the power from the utility through a surge suppressor and EMI filter and through the static switch. And here the UPS main components like rectifier, filter, inverter, all these things is going to the rectifier unit charges the battery, and the inverter unit is not going to do any function at this time. Now, when you want to change the mode, or the power is switched off, okay, the utility power is off. So this time now I need to take the energy from this battery. So when you want to take the power from the battery, so now what happens? So the power will be delivered from the battery to the inverter and AC filter, and then to the static switch, main static switch, and then it goes to the load. So in this time period, the static switch 1 is off, and rectifier does not do any work, DC filter is not going to do any work, and this EMI filter also not going to do any work. So the battery is going to deliver the power to the load. So this is a standby operation. So that means the UPS main components are in standby during the normal mode of operation, and during the power off or the utility supply is getting off, that time the UPS inverter is going to function, the battery is going to discharge the power to the load. So usually these standby UPS are used to protect individual loads like desktop computers. So these are low cost small devices, non-sinusoidal output waveforms, and high efficiency are typical attributes of these UPS types. Some standby UPS also provide surge suppressions, as I told you earlier, and electrical noise filtration. So the IEC standard classifies this type of UPS in these parameters: input dependency, voltage, and frequency dependent. So that means the output of the UPS depends upon the input voltage and also input frequency. And the second one, output voltage waveform. During normal mode of operation, it provides a sinusoidal output to the load, and during stored energy mode, it gives a square waveform output or a square output waveform to the load. And dynamic output performance in during the changeover time, it is going to provide 100 millisecond time. Okay, so it is going to have the delay, okay, and up to 10 milliseconds interruption time, and 20% voltage regulation to settle down. 20 milliseconds it takes to settle down, and almost 10 millisecond interruption will be there in both modes. Either you apply or remove the load, that time also it has the same surges. And when you are changing the mode between stored energy mode and normal mode, also it takes a time, 10 millisecond interruption will be there. The second one is a Ferro offline UPS system. It is very much similar to offline UPS system, except that it has a resonant transformer. So this resonant transformer is a specially designed transformer, so which is going to have a resonant property, So this resonant property is going to help us to suppress the noises, and also it is going to filter out the noises, and voltage regulation also will be done using this transformer. So apart from that, the remaining basic working principle is remaining same. So the static switch will be closed in the normal stage. So the power flow takes place through the transformer to the load, and also a certain amount of power will be passed through the battery charger to the battery. So this is a normal mode of operation. And these transformer coils provides the isolation, proper isolation between the load and the supply, and also it helps us to reduce the noise, and it produces a certain amount of voltage regulation, and waveform shaping also done using this transformer. And during the power off mode, or when the power is not available, the battery is going to deliver the load through the inverter and through the transformer to the load. So now this time the battery is going to give to the inverter input, so DC will be converted into AC, and the same function of the transformer takes place here also, filters the noise, voltage regulation and waveform shaping, and then it gives the output waveform. So this type of UPS has good performance against line noises. These transformers act as a conditioner, and it also maintains constant output to certain extent. The voltage regulation and output waveform shaping is also done. Isolation from AC power transients provided by this ferro transformer better than any other filter. But the ferro transformer itself creates a severe output voltage distortion and transients, which can be worse than a poor AC connections. Even though it is a standby UPS by design, the ferromagnetic standby ferro generates a great deal of heat. Because of that, ferro resonant transformer inherently inefficient. So the characteristics: it is big, heavy, and low efficient. On the other hand, we have the advantage of reliable, excellent line filtering. So these are the characteristics of this ferro offline UPS system. So this is about the UPS and its characteristics and types. In this next part, we are going to see the online UPS. We have double conversion UPS and delta conversion UPS. So in the double conversion UPS, we are going to see the internal circuit diagram and the explanation for the circuit and the block diagram and so on. And similarly for delta conversion also, we will see the circuit diagram, block diagram, and functional things and comparison between these different type of UPSs. Thank you. Thank you for watching.